Hello, everyone. It is 1 p.m. Central, so we will get started. Thank you for tuning in to today's presentation, Inspiring Students Through Hands-on STEM, Practical Tools for Real-World Learning. My name is Kelsey, and I will be your moderator for today's presentation. First, here is your 30-second introduction to Realityworks for those of you who aren't familiar with us. We are an employee-owned company based in Eau Claire, Wisconsin that creates experiential learning tools for teaching job and life skills. We got our start over 20 years ago when former NASA engineer Rick Germain created the first RealCare baby infant simulator and then went on to found the company that is now Realityworks. Today, our training tools combine curriculum with hands-on learning tools, student activities, and assessments. Baby is still around, but now you can look to us for our tools like our bovine birthing and ultrasound simulator, our virtual welding simulator, our wearable geriatric sensitivity suits. And if you have some time, we encourage you to check out our website and see it all. Presenting today, we have Todd Hunter, who is the STEM and Career Exploration Product Manager here at Realityworks. Todd is an experienced educator in leading innovative curriculum design, and he has over 19 years of experience as a STEAM teacher and program development in Minnesota. Before we get started, I want to cover a couple things. First, today's presentation has been pre-recorded, and all attendees will receive a link containing the recording, as well as a copy of the PowerPoint slides and free resources. For those of you attending live today, you'll also receive a certificate of completion for attending today's presentation. Keep an eye on your email. You will receive that email within 24 hours after the presentation, and we will have time at the end for Q&A, so feel free to type your questions in the chat or Q&A feature located at the bottom of your screen. With that being said, I'm going to go ahead and pass things over to Todd.
My name is Todd Hunter, like Kelsey said. And before we jump into what we have planned for today, just want to give you a heads up on who I am. I was a classroom teacher at the high school level for 19 years, working first in science and then transitioning more to CTE, engineering, tech ed, because they get to do way more fun stuff before eventually transitioning into an admin role. And part of my experience was building and fleshing out a STEAM program, which really gave me a valuable set of experience as I work now with Realityworks, developing really powerful tools for STEM learning. So let's jump into, right, and just make sure we're all on the same page. Our goal, whether we are a teacher ourselves or you are somebody who supports teachers from a different level, is trying to help create these super engaging atmospheres and learning environments for our students. And we know what that looks like. When you walk into a classroom and you see it, you know it right away. There's no question. And yet today, a lot of times it feels like this is what we walk into our classrooms. Half the students are distracted with their devices, and the other half, I don't even know what those chickens are doing, but that kind of describes oftentimes many of my students, right? So what we strive to do and what I want to do, and a lot of us in education, is try to find ways to help our teachers and our students get to that high level of engagement. And for us, and for me, as somebody in my background, that to me means STEM-powered learning. And so at Realityworks, we invest quite a bit of time and energy into developing products that support teachers in creating those environments. Today, we're going to look at four. First, these three, but then you guys get the first deep dive into our new Trailer Circuit STEM kit, which is super cool. So I'm going to take some time. We're going to jump into each of these. Got some information. We'll look at some of the curriculum. I got some short videos to demo, right? But also, I want to make sure that you understand why I'm including these. When we look at the research behind, okay, what is it that makes STEM learning effective? It's not random. There is a method behind that madness that gets our students and our teachers to create really engaging environments. And this is what we call the STEM 7, and it's how we hold ourselves accountable to building really great STEM products. So the first one is it's got to bring in and get students excited about real world problems. Two, we want to see engagement in engineering design. That's a really important part of the STEM learning environment. Three and four, context integration, meaning let's address that ever-present question we hear from students, why do I have to learn this? And then content integration, and let's bring what we learn in math class to this environment, what we learn in science class to this learning experience. When I'm using this tool or troubleshooting with this piece of technology, I want to see it all together, not in these random isolated silos. Engagement in authentic STEM practices, that means looking at data, right? Reasoning as you develop and produce 21st century skills where we have communication, teamwork. Those are the things that our employers want to see. And then lastly, if we have a really engaging STEM experience, that means we're also setting the stage for students building awareness of STEM careers for their future. So that's what we look at as we look at, products that we identify as being STEM powered. The first one we're going to jump into is the RC Tractor Pull Challenge. Now, depending on your own context, where your school is at, this might or might not be something that your students experience. I know that I have never met a student, whether you're actually at a tractor pull or just watching a cool video that you find on YouTube, who is like, that looks stupid. These things are so much fun. And it's such a great context, right? That's one of our things when we talk about STEM, to learn a ton of different ideas, physics and engineering, and also just, like from the automotive world, how do these things work? So in this package, you get a really amazing set of products and a curriculum that goes with it. What I really like about this, and this is one of the things that stands out, and you'll see in the video shortly, is that this is not a one-trick pony. Right? The RC tractor has been designed so that students can take it apart and really dive into that engineering design. Right? They can test different spur gears, pinion gears, they can move the weights around, they can change the wheels, and then they actually get to respond to that data that they gather as they attempt that challenge of building the strongest or the fastest tractor. Let's take a look at this quick video so you guys can see it in scale. All right, so let's take a look at the RC Tractor Pull Challenge. Tractor Pull Challenge comes with 5 RC tractors and 1 pulling sled. Each tractor comes in its own box, and inside the cover, the students will see exactly how to pack the box and then a key explaining all the parts. Now, the tractor is pretty amazing in that it's not a one size fits all. It's really about what's the optimal way to build a tractor that can pull either the fastest or the most weight, which means the tractor has a lot of different ways for customization. Now, students can very easily pop off the top, and now you have access to changing all the different components. It comes with 2 different wheel sizes. It comes with 2 different pinion gears that you can swap out, 3 different spur gears, different tooth numbers, different sizes. And then I can redistribute the weights with 60 washers that lets you move the weight front, back, left, and right. And then I can also change the height of the hitch, the tow hitch, which is actually quite important. This really lets students dive into gathering data, evidence, running different trials as they figure out what are the different variables that influence how the tractor pulls. Now with the sled, you also get 12 1-pound weights, which adds up pretty fast. And so when students are ready to test, all they do is attach the sled to the tractor and it's ready to drive. Right. Now, as part of this, we really do try to do our best to support teachers. And so with this comes a pretty extensive curriculum that you can pick and choose what you want to use in your own classroom, right? And what's really cool is, again, bringing that STEM engagement learning, we want to bring in lots of different topics. for that student who always says, why do I have to learn this? Right? This is where they finally get to see that learning take off. So lesson one, right, they introduce themselves to the tractor. Lesson two, that's when they actually start changing up different variables. Lesson three is all about sort of the physics of gear ratios. And then lesson four, this is super cool. You apply Newton's third law, actually do some math, do some trig, and some of the physics concepts that a lot of times students never hear used in real context get pulled in. And then lastly, once they've learned all of these different ways of modifying and thinking about the tractor, you get to have that big contest at the end and see who can pull the most. So this does come with 5 total. So it really is set up for a successful classroom experience. And that means that your students get to work in teams, break up, and they get to sort of reason their way through the different variables. What's also kind of cool is for those students who are just, like flying ahead or have some other skills from other classes, we provide those CAD drawings where they can actually 3D print and customize their own tractor. All right. Where does this fit? So we have seen teachers implement this product in a ton of different areas because it does bring in so many different topics and sort of build awareness of all these different ways that you could use this learning, different STEM careers. The next one I want to take a look at is our electrical wiring kit. And this one comes from listening to our teachers. And these are all the comments that we've heard from our teachers, especially working in the trades, construction, carpentry. Some classes even just go straight to the wiring, right? How do I teach this? How do I bring this into my classroom? And so we worked with our team of engineers to bring this real world problem into the classroom, which short of ripping the drywall off of your classroom wall, you can't get much more real than this. So whether the student is going to be an electrician or not, this is one of the products that lays the foundation for so much success. Not only is teaching real skills with the same, not, sorry, not only is it teaching real skills with the same materials, tools, and tactics that an electrician would need, but it also builds an understanding of electrical wiring, which translates into so many different career fields, from being a manufacturing technician, working in HVAC, mechatronics, robotics, engineering, and just science in general, too. Now, to really facilitate the learning that we, encourage in our classroom, our engineers created this really, really cool assessment tool. And that allows our students to engage in that engineering and design process because it, one, allows them to mess up, and two, it tells them how they've messed up. So the assessment tool uses AA batteries to test the circuit and provide feedback to the student, which means you as the teacher don't have to intervene every time they do something. You can set the challenge and let them problem solve and experiment until the assessment tool confirms that they did it right. The assessment tool also allows students to gauge in authentic STEM practice of making observations, collecting data, and responding. Students really get the chance to experience that it's not working. What does the tester say? And then work to interpret the code that it throws on the screen. This really develops that higher level of critical thinking that we want our students to engage in, and being able to interpret that code shows real understanding. Here's a quick video which puts it into context. So I have this unit set up for demonstrations. Normally you wouldn't have 3 different circuits. I've got this wired up on its own. I've got these 2 on its own, and then I have the outlet light and a single pole switch. This is mostly just for demonstration for today. You could do it however you wanted. You could have students do any sort of arrangement. And we do have the different activities that are in the workbook. But there is a lot of freedom for you as the teacher to decide how you want to pull this off. Now I switched this up. I connected this box, this light, and this switch to my control unit. So let me go ahead and plug in my assessment tools. and flip on the switch. Now, right away, I can see my outlet tester, which is evaluating this. It's giving me a code that says correct. However, my light socket tester, I got two signs that things are not working appropriately here. One, it's not lighting up. If I flip the switch, I'm not getting power. Right? But I can also see when I flip the switch that the code changes. And if I look at that, I get a hot neutral swapped. Now, what's fantastic is I can do this as a student and as a teacher confidently because I'm not using, well, I have 120 volt AC power. I'm just using this battery powered assessment unit, which
I'm sorry, the audio goes weird there.
and not cause trouble, not start things on fire, and keep things really safe.
Right. I do want to mention that in this unit you're seeing, we cut it in half. This is one of our trade show units, so we package it and travel around. You'll see pictures of the actual one that's not split in half like that. Right. The curriculum that we provide really does a phenomenal job of creating a roadmap for the teacher. It comes with 3 lessons with slide decks, which are great universal fundamental electrical knowledge pieces. And these lessons each come with student worksheets and completed keys for the teacher. For the wall kit, there are 12 exercises that you get everything you need for. And we include instructions for 4 additional exercises that you do need to find your own components for. Now, what is nice about this is that the electrical components are universal, so there's no need for special parts. My guess is you probably already have some laying around or they're easy to find. Even asking your custodial staff for a fried component could be a really fun way to level up the training that you put in front of your students. Here's some of the examples of what we provide. And what I really like is how the curriculum melds together the context and the content of the learning. Wiring skills are super relatable when they're taught in this real context because every kid's got this stuff at home. But I really value how our curriculum writer created the wiring exercises and worksheet questions to unite the world of physics and electricity, math with Ohm's law, and then the visuals that an electrician would refer to when installing fixtures. The experience that the student has is directly connected to the real world, which is incredibly powerful. Oh, okay. So this is some great examples of how teachers that we work with implement this. Um, you can see in these pictures the size makes it really easy to implement anywhere. You don't have to be connected to a wall or a tabletop that has power. The assessment unit, being that it's battery powered, allows you to set this up anywhere. And then when you're not using it, it's easy to move it to a place for storage. One of the things that our teachers does that I was always really impressed with is how they use teams with this product. So for example, they would use a group of 3. One is acting as the electrician, another is serving as kind of like the guide, giving instructions, looking at the materials, and the third is what they would call the apprentice, who is there to offer that extra helping hand. And then this collaboration and teamwork, especially as they work through troubleshooting and reading those codes, is a great way for students to develop those 21st century skills. The last one before we get to our new one is our measurement math training kit. Now, this one addresses one of those fundamental pieces of learning that so many of our students really struggle with, and many of our teachers have a hard time engaging students in. In my classroom, I use detours, or what I sometimes would call skill checks, that students had to complete before they can move on further with their projects. One of the tricks of teaching measurement is to make the student suffer a little bit before you send them on this detour, because we all know where they're going to mess up with bad measurements, but we can try to prepare them all day ahead of time. They're not going to listen, right? Until they've failed a little bit and their brains are primed with their own motivation, and that can drive them through learning how to finally make really precise measurements. As far as context goes, measuring real things is important. There's lots of products out there where you just measure stuff on a piece of paper, but it's so different when it comes to measuring real physical objects.
Also, thinking about transferring their learning, we want you to use your own measuring tools. We do provide a ruler, a really nice metal ruler, but students, when we think about transference of understanding, right, is they've got to do it and they've got to learn on the tools that you want them to act on. And so we guide them through all of these different learnings, right, but we really want them to be set up for success in your classroom. And so we want you to use the tools that you provide. Now, from a curriculum perspective, what's kind of nice is this is more a la carte style. You don't need to follow this all in order. It really depends on what is it that you want your students to develop. And so you can pick and choose as a teacher. Here's a quick video that shows them in use.
All right, let's break open the measurement math training kit. Now this comes with 5 of these boxes, which makes it super easy for the teachers to just hand out in class to a student or a group or a pair of students. When they open that box up, right on the lid, it tells them exactly what they're going to get. So they've got their super precise metal ruler, and then there are 5 very precisely cut, really thick and burly acrylic manipulatives. Now, each of those manipulatives, here's number 2, are clearly labeled. They're all different, so you cannot see them on the table. And there's number 5. And what's fantastic about these is that, one, you're not going to find anything else out there in this shape, right? But they are made to correspond directly with the student workbook that's provided with this product, which you can also print off on your own, right? And because they're all numbered 1, 2, 3, 4, and 5 very clearly, here's number 4. It's really easy for students to figure out, what am I supposed to be doing based on the instructions they're given. But then what I also really like is that each face is clearly marked and identified using the letters of the alphabet. And because these are precisely cut, so these are laser cuts out of, it looks like 1/4-inch acrylic, you can have really high expectations for the precision measurements that students can make with these. So phenomenal practice for students as they develop their ability to do different types of measurements. And we provide the ruler, but you can use anything. If you want to use a tape measure, if you want to use digital calipers, these will work for anything. What I also like is that they have pretty complex angles. And so you can really challenge students to make measurements, right? Precise measurements, no matter what the shape, even some circles, which is really important for things like diameter. And then you can even get into calculating circumference if you wanted to. When you're all done, the students can just pack it up back in the box, nice slotted foam, and it's ready to go for the next student.
Awesome. Complementing each lesson's slide decks is the student workbook, which gives students opportunities to practice the lesson skills and also present visuals that support them. And then all of these things are ready to load up into your LMS, whether it's Google Classroom or whatever. We also provide assessment tools that you can choose to utilize as you best see fit, such as this exit ticket or post assessment. And I'm not going to go through all the 7. I really view this as a support piece to a STEM environment. You know, we know that measurement is a fundamental skill to set our students up for success in pretty much every field. And so this is a part of that complete package. Teaching electricity is a double-edged sword. Students are always excited to learn about electricity because it seems kind of like magic. You know, things are moving and lighting up, but oftentimes they're scared, thinking they're going to get shocked or they're going to blow something up. And that apprehensive mindset often works its way into the teacher's brains, resulting in a learning experience that tends to be more hypothetical or demonstrative instead of an experience that really builds transferable learning. When we look at all the things there are to learn about to prepare students for STEM futures, understanding electricity, I would say, is a universal modern day foundation that they need. Whether it's future engineers in any field or technicians working in manufacturing or automation, your service tech at the auto dealer, or even someone thinking about health science and medical future, you've got to understand electricity. And where it gets challenging is that we are asking students to wrap their head around an invisible force. And for a lot of our learners who need to see their learning affect the real world, that's a big leap to take. And that's the beauty of the Trailer Circuit STEM kit. We combine electrical learning with real world context of a trailer where you can immediately see the effect of your learning right in front of you. So this idea actually came from our ag teachers. We spent a lot of time listening to our teachers. And ag teachers are unique because they tend to teach everything. They were bringing cars and trucks and tractors to school and hooking up different trailers and wiring them. But that's only so effective when you have a class of 20 to 30 students, and it's completely off the table if you don't have a big shop to work in. So we took that idea and we shrunk it down to a desktop size. But the simulator matches exactly what you'd find wiring a real trailer. We use that universal four-way connector that you would see on any vehicle, um, all the way up to a really fancy, powerful seven-way that like my camper has for making that connection. And this vehicle trailer context is what creates an amazing bridge for students to see how what they are learning is applicable, beyond theory. As an engineering teacher, framing learning experiences as a challenge is really important. And so what's really cool is instead of saying, hey, we're going to learn series and parallel circuits, right? It's, hey, can you wire a four-way trailer so all the lights work? Hidden in that challenge is so much learning, but it's way more engaging from the student's perspective when you frame it as a challenge. Here's a quick video.
Welcome to the Trailer Circuit STEM Kit. The Trailer Circuit STEM Kit is a really convenient and easy way to teach electricity in a way that is really transferable to the real world because we built it to match exactly what a student might find on a car and a trailer, whether it's a simple passenger or all the way up to a truck with a fancy seven-way connector. And we wrote this curriculum and created this product with the assumption that students might not know anything about electricity. And so we begin really simple, teaching the difference between AC and DC, introducing series circuits and building a simple series circuit and testing it here on the simulator, and then a parallel circuit. We then move on to the four-way connector, just like they would find on a regular passenger car. We teach students how to use the tools to strip wires, add crimp connectors, make the connections, and then of course, they can turn on the simulator and test the connection to make sure it works just like you would with a real trailer. And once the four-way is done, then we upgrade to the seven-way. The seven-way gets quite a bit much more complex. We direct students through taking the seven-way apart, removing the wiring terminals, making all the connections on both the vehicle and the trailer side, and then finally making all the connections one piece at a time. Just like on a real trailer, and then make the connection between the two. Now it's time to test. I turn this, I can test the lights, and now I can see all of the side and rear marker lights are turned on. Test the right blinker, there it goes. Left blinker, brake lights, and I can also see the indicator lights for the trailer's brake system, and then of course the reverse lights. Now, that's not where it starts or ends, I should say. Just like with the real trailer, sometimes things don't work. And so also built into this product are 10 troubleshooting scenarios. Scenario 0 is just, hey, everything works great. If I use the button, I can select to zero number 1 or scenario number 1, and you can see here's 0, normal operating mode, scenario 1, the lower right marker light burns out. Why did that happen? And this is where the curriculum gets really, really valuable. It teaches students how to use an auto test light and a multimeter to troubleshoot a circuit and to figure out, okay, why does that light not work? Now, there's 10 troubleshooting scenarios built in. Once students have worked through all of them, then the teacher can enter into assessment mode where students get a chance to show how well they truly understand what it is that they've learned. Also, one thing I wanted to point out is we even have a working fuse panel. Your students need to check the fuses with the multimeter to make sure that everything is working as expected. All right, that guy's videos, geez. So this really is a phenomenal package. The curriculum I'm super excited about. Like I wish I had this when I was a teacher. When we talk about integrating content, lesson 1 and 2 dive into those electrical concepts and understandings that are needed later, right? Diving into the difference between voltage, current, resistance, power, AC and DC power, series and parallel circuits. And then right away in lesson 2, we get them building, right? So it's not just staying as conceptual, we want them to see it. And they build it right on the simulator. So there are 8 lessons total. You can see them on the left side there. And we prepped them in what I call our upload and go format. So they're ready to put into your LMS. And what I really like about how we've done this is that it supports students working as independent teams. The slide decks for each lesson are made so that you as the teacher aren't the one delivering the content. By freeing up the teacher, right, to be a roving troubleshooter and what I call a learning accelerator, we put the responsibility of engagement on the student's shoulders, which develops those important 21st century skill sets of independence, ownership, and time management. And throughout, students are engaging in this really phenomenal integrated learning experience where they use math, they use like Ohm's law, they're developing communication skills as they follow along with the student workbook, and they're developing that understanding of these really amazing electrical concepts. All right, I gotta keep, there we go. Right. Each chapter's learning is reinforced in the student workbook, which we've modeled after the classic engineering notebook. This becomes the students' notes, their reference material, and a really wonderful resource even after they're done with this unit and are working on future projects that require electrical understanding. So this really does become a phenomenal foundation for what comes next in your learning. We also provide, right, trying to think about what the teacher needs, pre and post assessments with the keys already made. And then for the teacher's ease, we have a key of the whole student workbook so that you kind of know, okay, what should they be aiming for as they're working through their process. One of the very purposeful efforts we made to set students up for success was making sure that they intentionally develop their tool literacy, showing explicitly how and when to use the tools. The wire stripper and crimping tool is a perfect example. Many students are coming to school, they don't know how to use that. And the multimeter is in the same boat. It's such a powerful tool, but it takes really direct instruction and practice to learn how to use it. These are the same tools that are used in a ton of STEM related fields, from trades as an electrician or an auto mechanic to robotics and microelectronics. A multimeter is a tool that students should be comfortable using, and this really does help them. Again, as a teacher, I wish I had had this. All right, which brings me to my favorite feature of this whole simulator, the 10 built-in troubleshooting scenarios. If you've ever tried to teach students to troubleshoot a circuit that they've built because it isn't working, it's really hard. So once students have finished working through lessons 1 through 6, that means they have a fully operating trailer connected by the complex 7-way harness. And just like you should always test a trailer before you head out on the road, in the real world, right, things don't always work. So lesson 7 does a really cool thing. It presents common causes of electrical faults, then provides a process for troubleshooting and guides them through this process in scenario number 1 so they can see how it works. Then lesson 8 challenges them to work through scenarios 2 through 10. Each one is different. My favorites are one scenario turns everything off because they have to remember to test the fuses. And then the other one is there's our engineers did a really cool job of
programming in one of the lights that just starts flickering randomly to model a loose connection like you would find on a trailer if a wire wasn't, secured. Now, what's amazing about this, right, is we're teaching them a structure to their thinking. And so this sets the stage for what you're doing next, whatever the context. Anytime they're wiring something, building a circuit, robotics, whatever, right, now you can go back to this troubleshooting process and say, hey, remember how we did that? Revisit, use those same skills now. Okay, then one of the questions that always comes up is what about safety? All right. What brings this simulator right to the next level is that our engineers invested a ton of energy in making this behave as much as possible like a real trailer and vehicle, which means that the multimeter, when you're testing connections, right, or even using the auto test light, you read, you measure the same as you would on a real trailer. At the end of the day, though, it truly is an engineering trick because in reality, this whole thing, if you flip it over, is powered by 4 AA batteries, which last hours. We've had this thing here at Kelsey. It's lasted like we left it on for 2 days straight, which you would never do in a classroom, and the batteries were still rocking. But with 4 AA batteries, that's a maximum you can have of 6 volts, which could never pack the punch of a car battery. And as I was working with this product and helping develop it, I kind of tapped into my 19 years of experience watching students try to break everything. And I tested this in as many ways as possible. There is no way to fry parts, to cause short circuits that result in high temperatures and melting things, or even to burn out a light bulb. And that's what's so valuable about this. We need students to be comfortable with failure, with testing and evaluating when things do go right. And they can do this with the STEM kit because we've removed that fear that so often gets in the way when it comes to teaching electricity. So cool. Okay, this is just a real quick big picture look. We set this up. You get a package of 3 of these. That includes 3 complete sets. So 3 sets of tools, 3 sets of multimeters. Um, and what's great is this thing is sized to fit on a desk or a tabletop, letting students really get in there um, and work together, which is pretty cool. These are our 4. We have tons of different products that are out there that do support STEM, but these are the 4 that I think really do a phenomenal job in enhancing those STEM classrooms. I'm going to stay on here, and now I'm going to turn it over to Kelsey as we begin to wrap it up.
Perfect. Thank you, Todd. So before we did have a couple questions rolling before we jump into those. If you are interested in any of the products that we talked about today or connecting with your local Realityworks account manager, you can scan the QR code on your screen and we will get you connected with that Realityworks rep in your state. So if you're interested in that, feel free to do that. And then we will jump into some questions now, Todd. What classes would benefit from the RC Tractor Pull Challenge?
We have seen the RC Tractor Pull Challenge put into, let's see, gosh, it's hard depending on where you are in the nation. A lot of our ag teachers love it because they're teaching ag mechanics or they're just looking for a really great way to introduce sort of the physics and STEM concepts into their ag classroom. We've also seen it brought into a lot of engineering classes who are looking at gear ratios and weight distribution and also want a contextual way to talk about things like friction and Newton's laws and how does that actually influence how a vehicle moves. I've even seen it in some places where you would never expect it, your autos class, where the teacher, is trying to find ways to engage students because they don't have enough auto bays for students to work on the cars. And so they'll have students engage with the RC tractor because, again, you're still learning concepts that, connect exactly with what you would see on a car. And then even at the middle school and high school level, leaving the CTE world in the science classrooms, those concepts show up all over the place from middle school to high school: physics, physical science, even AP and advanced CIS physics. We've seen the teachers implementing them there.
Perfect. All right. Awesome. Well, I don't see any other questions then at this time, Todd.
Awesome. Well, thank you so much, everybody, for taking time to join us. And please let us know if you have any questions. And we look forward to working with you in the future. Thanks so much.